Okay, guys, I'm so sorry for technical glitches. So let's continue. So this work was completed when I was interned at Adobe Research last year and has been published at ACM Tokai. So to begin with, providing asynchronous feedback is crucial in 3D design review workflow. So it allows all stakeholders, such as collaborators and clients, to review the design, highlighting issues, and propose changes. So many of software applications, such as Adobe Acrobat, allows feedback providers to anchor textual comments to a specific views. However, this is often insufficient, as the text alone can be difficult to convey the gist of the feedback. Therefore, feedback providers often pair text with a companion reference images, which helps illustrate the gist of the text. So to do that, feedback providers may first load and explore the 3D models. They may start writing some textual comment in an email notes. So for example, in this case, the design feedback may be try to change the red wall paint of this room and use a curved computer display. So to realize this, feedback providers may need to identify a suitable viewpoint and find the reference images from online search engines, such as Pinterest. And finally, they may attach a reference image to a design feedback and send it to the designers. So as you can see, this process is not easy. Exploring 3D models is time-consuming, insufficient, and might be difficult for those feedback providers without 3D experience. Finding a well-matched reference images is also not easy and sometimes nearly impossible. And finally, inaccurate reference images could hinder designers' understanding of the feedback. Alternatively, feedback providers can also use the vanilla text-to-image GenAI to generate the reference images. So these are some possible examples generated by Adobe Firefly. But as you can see here, these reference images are not contextualized on the initial design and can create misunderstanding for the designers. To address this challenge, we introduced MemoVis, which is a generative AI-powered text editor interface for creating companion reference images for 3D design feedback. Let's first take a look of how feedback provider may create the reference images as part of 3D design feedback. Like the previous workflow, after loading the 3D models, the feedback providers can first load and explore the scene. The feedback providers can then start typing some textual comments. For example, the feedback can be change the wall paint to red. Once finished, MemoVis will suggest some well-matched views using a hovering dialog with a thumbnail of the suggested perspectives. Feedback providers could easily pick and try out each views and compare different views to decide on one of them. So how do we realize this viewpoint suggestion feature? So at high level, MemoVis took advantages of human preferences presented in the training data of clip model. When the 3D model is initially loaded, MemoVis uniformly samples various views by positioning the cameras as different locations inside the model. So each view can be parameterized by a tuple. With a clip image encoder, we then compute the embeddings of each sampled views. The view embedding matrices can be stored persistently. Upon feedback providers completing typing each texture input, MemoVis can identify the top 4 views by comparing the texture embeddings with the stored view embedding matrix to a nearest neighbor search. Next, given a specific perspective, instead of asking feedback providers to search reference images from the internet, they can simply write a texture prompt which could generate the reference images contextualized on the current view. But as you can see here, many other things, such as the color of the wall, except the color of the wall, also changed, which is not really what the original design looks like. Therefore, the feedback providers can simply draw a cropping box, and MemoVis could be smart enough to extract the underlying structure and overlay on top of the initial design. Feedback providers could then finish up their feedback writing and with a nice reference images. So how do we realize this? So essentially, we achieve this by leveraging a combination of control net and segmented anything model. We first use the control net to generate the image from the texture prompt conditioned on the depth map. We then use the segmented anything model to extract the primary objects within the bounding box defined by the feedback providers and overlay them on the initial design. So let's possibly also suggest more complicated comments, such as change the current computer display to a curved one. To realize this, feedback providers could quickly draw the rough shape of the display, describe it with a texture prompt, and then hit OK. So now, MemoVis could smartly generate the reference images with a nice curved computer display. To realize this, we first use ControlNet to generate the synthesized images conditioned on both depth and scribble input. Afterward, we then apply the segmented anything model to extract the suggested objects from the synthesized images using the mask inferred from the user scribble. This will allow feedback providers to visualize the proposed changes within the context of the initial design. We finally also created a painting feature to support feedback providers to specify the area of changes, such as simply add a paint on the wall. So they can quickly paint the areas, describe the picture styles, and then hit OK. So eventually, the feedback providers could put everything in a memo or email notes and send it to their designers. We realized this with a dedicated designed rich text editor interface supported by a set of vision language foundation models and deployed on Adobe Sensei Cloud. To evaluate the MemoVis, we conducted 2 user studies. Our first user studies aims to assess the experience of feedback provider while creating reference images with MemoVis. On the other side, our second study aims to evaluate the quality of the reference image. In our first user study, we recruited 14 feedback provider participants. And here we focus on 2 primary research questions: how the real-time viewpoint suggestion features can help feedback providers to navigate the 3D scene while creating feedback, and how the image modifiers can help feedback providers visualize the texture comments for 3D design. Participants were invited to evaluate 2 interface conditions. For the baseline condition, participants can create the reference images using the image search from the search engine or the hand sketching. Whereas with the MemoVis condition, the reference images will be created by our system. Participants were required to create reference images along with the texture comments based on 3 3D models, where the first 3D model was only used for getting familiar with the system. Through our user study, we found feedback providers find it easy to navigate the view, to create the reference images, to appreciate the explicitness of the created reference images, and to gather a fresh inspirations from the new feedback and ideas. In the second study, we evaluate the quality of the created reference images. Instead of focusing on the aesthetics, our goal is trying to understand how well the reference images can convey the gist of the texture comments. Our results demonstrate a higher percentage of the design feedback created using MemoVis received more positive ratings. At the end, we want to show some example reference images created by the feedback providers using MemoVis, illustrating suggestions such as adding an indoor plant, modifying the wall design, and also including a wall poster. In contrast, without the MemoVis, interpreting the design feedback through search and annotated reference images can be more challenging, and sometimes it can cause misunderstandings to the 3D designers. For more details, please refer to our paper. And at the end, I also want to highlight that this work also marks the conclusion of my PhD research at UCSD, contributing many of my endeavors to enhance the content interaction experience for a wide variety of 3D interfaces. And more specifically, I address 3 hard yet important challenges, including how to create the reference images while reviewing 3D models rendered on 2D display, how to connect the instruction document with the physical space rendered through mixed reality, and how do you augment the interactions with 3D data, such as medical image scannings, volumetrically rendered inside the virtual reality. With that, I'm also on the job market this year, so I'm looking for a full-time research position in the United States. And if you are interested in our work, feel free to drop by our poster stands. I'm happy to answer any questions you may have, and thank you.
Any questions? All right, I have a question. So how do you envision the system can be integrated into the future workplace applications?
Yes, thank you, Liang, the session chair. So I think that's a great question. So in the current research, we're trying to understand the feasibility of using generative AI to create a reference image during 3D design feedback workflow. So currently, we are really just build a simple prototype to test out this kind of feasibility, to tease out the system design. In the long run, MemoVis can kind of be integrated into many, text-driven or text-first document tools or web-based applications. So for example, you can kind of design a MemoVis as sort of like a plugin, right? So for the Gmail text editor, you can also integrate the MemoVis as like a plugin in Teams or Slack, this kind of instant messaging applications. So where feedback providers can quickly create feedback while focusing on their primary task, which is really creating feedback and then typing text instead of focusing on how to edit the images, which is what people are doing nowadays. That is not very efficient and kind of time-consuming. Thank you.
All right, so this is the end of the presentation.